All right, this section is 6.5. It's all about solving radical equations. This is an equation because it has the equal sign and it has the radical symbol in it, so this would be a radical equation. When you solve equations, you always do the opposite operations. So, for example, adding, subtracting, opposite of each other. Multiplying, dividing, opposite of each other. Opposites are everywhere. You know, left, right, up, down, etc., etc. But we're not going to use left and right here. We're using these kind of ideas. Square root. The opposite of square root would be squaring. Cube root. The opposite of cube root would be cubing. So there's opposites everywhere in math. We're going to use those to solve. The next thing we want to think about is we want to always step 1 or step 1 and 2 or whatever it takes is you want to isolate the radical. Get the radical by itself. So isolate the radical. Isolate the radical. Get the radical by itself. So we're going to do that here. We're going to move this 7 over. We're going to get this radical by itself. So I'm going to move this 7. It's a positive 7. The opposite would be subtract 7 from each side. So we get radical 2x minus 1 is equal to 3. Now we can talk about squaring. The opposite of square rooting is to square. So I square each side. But see, the first thing I did is I isolated the radical. You can't square each side from up here because it'll create a big mess. You gotta isolate the radical first. So I square each side, and the radical goes away. Out falls 2x minus 1. You square this, you get 9. Now I've reduced it to an Algebra 1 problem. I'm going to add the 1 over, get 2x is equal to 10, and then divide by 2, so you get x by itself. Now with these types of problems, it's very important to try the solution back in the original, because sometimes you can get a number down here that won't go back into the original. There's restricted numbers that go into the x because you can't take the square root for a negative number, for example. So let's put 5 back in, get a different color. So I'm going to put 5 in here for x. So it would be 2 times 5 is 10, minus 1 is 9. The square root of 9 is 3. 7 plus 3 does indeed equal 10. So it works. Example 2. Okay, question 2. We are going to isolate the radical. There's no radical here, but there is, because that means, take the cube root. So we're going to do the opposite. This is 4 times this amount here. So I'm going to divide each side by 4. Luckily, it comes out to 2. So it's x minus 4, 1/3 is equal to 2. Oh, just broke my lead. Now we're going to do the opposite of this power. Well, one way to think about this is all the students know the exponents E-I-E-I-O. The top number is the exponent, the bottom number is the index. So if you change that around, you would make the index into the exponent and the exponent into the index. So it flips the fraction upside down. So 3/1 would be like cubing each side. So the opposite of the cube root or the 1/3 power is to cube each side. So this cancels out because 3 divided by 3 is 1, 1 divided by 1 is 1, so this is all just 1s. And out drops x plus 9. Minus 9, not plus 9. And that's equal to 8. Subtract or add the 9 over, x equals 17. Now we should make sure that this works. 17 minus 9 is 8. The cube root of 8 is 2. 2 times the 4 in the front makes the 8. So it works. All right, but what I did here is I did the opposite. I have 1/3, and I flipped it upside down, made it 3 over 1. And I did that to each side. See, that's really 3 over 1. So if you had a 2/3 here, you do 3/2. You just literally take this fraction and flip it upside down. That's the inverse operation, because you're taking the index, making it the exponent, and the exponent making the index. That's 100% backwards, and that's how you solve equations. You always do things backwards. All right, this one here. The radical is isolated, so that's part of it is to isolate the radical. That part is done. So I don't have to like move anything over. I'm just going to start by squaring each side of the equation. Squaring the square root makes the square root goes away, and I'm left with 2x minus 1 is equal to. Now when you square a binomial, you have to write it down twice. X minus 8, x minus 8. 2x minus 1 falls down. Distribute. X squared minus 8x minus 8x plus 64. 2x minus 1 is equal to x squared minus, put these together, 16x plus 64. Oh man, I'm getting tired. It's after school. Now I have to solve this. How do you solve a quadratic? You always set your quadratics equal to 0. So I'm going to move these two bad boys over to get the quadratics set equal to 0. So this cancels out, that cancels out, that makes 0. Get x squared minus 18x plus 65 equals 0. Now, isn't it 13? 13 times 5 makes 65. But man, the sleepies just hit me. I need a burst of energy or something like that. So 13 times 5 is 65. So it's 13 and 5. So we do 2 sets of parentheses, put an x in each. So it's minus 13 minus 5, 0 product property, x minus 13 equals 0, x minus 5 equals 0. So x is 13, x is equal to 5. Now this time I got 2 answers, and I'm really suspicious about whether 2 answers will work. So I'm going to go back to the original problem to see if the 2 answers will work. I got x is 13, x is 5. So x equals 13, x equals 5. I need to go back to the original problem, so therefore this isn't here. And the squaring's not there, so I'm erasing it out. Okay, and then I put 13 in. Does 13 work? Well, 2 times 13 is 26. Minus 1 is 25. The square root of 25 is 5. So I get 5 on this side. 13 minus 8 is 5. So 5 and 5. So that checks out. The solution is okay. Now we put in 8 or 5. 10 minus 1, by putting 5 there you get 10 minus 1 is 9. Square root of 9 is 3. 5 minus 8, excuse me, is negative 3. So 3 and negative 3, they're not the same. So 5 does not work. So down here, we say that 5 is an extra solution, but extra in a bad way. And the fancy word for that is it's an extraneous solution. Okay, so extraneous is extra in a bad way, like extraneous work. But there's no such thing as extraneous pizza, right? Because you always want extra pizza. So 13 is the only solution that works for this.